Hi everyone, we will talk about linear differential equations with constant coefficient of order 1 today. So this is the general form of first order linear differential equation with constant coefficient. That is y dot equals ay plus b. Don't forget y dot here is dy dt. How y changes with respect to t. This is the same as derivative of y with respect to t. So in this first semester, we have known the solution of y dot equals ay plus b by using separation of variable technique. So we were just going to discuss the same technique, that is using separation of variable. So first of all, I know y dot is dy dt. So I can get y to the left hand side, and all variable with t goes to the right hand side. So I have this equation, so I can integrate both of the left hand side and right hand side of the equation. So if you remember, in the first semester we have talked about what is the integral of 1 over x. This is natural logarithm of the absolute value of x plus k. But we can just what is the integral of 1 over ax plus b dx. We can just use the table of integral, and the answer is 1 over a natural logarithm of the absolute value of ax plus b, a plus constant. So I have this one is this, and what is the integral of dt? So it should have integral also here. So the integral dt is t plus constant, and this one is 1 over a ln natural logarithm of ay plus b. So I can multiply by a, and this is the same as this. If I have ln x equals y, so in the exponent, we can talk about this is the same as e to the y equals x. So I have e to the at plus k equals the absolute value of ay plus b. So don't forget, we want to have what is y in this one. So if we open up the absolute value, I have ay plus b equals some constant times e to the at. Don't forget, e to the at plus k is the same as e to the at times e to the k, but e to the k just another constant. Another constant times plus or minus came from this absolute value. So I have ay plus b is a new constant times e to the at. I can get b to the right hand side, so I have a minus b, and if a is not 0, I have y equals k times e to the at minus b over a. So if I have y dot equals a y plus b, the solution is given by k e to the at plus minus b over a when a is not 0. But when a is 0, y dot equals b. This is the same as dy dt equals b, and the solution is given by yt equals bt plus k. So another question, if I have known what is the solution of this differential first order linear autonomous differential equation is this when a is not 0 and this when a is 0, I want to ask, are there any steady state solution of the first order differential equation, autonomous linear differential equation this? If there is, on what condition will the solution converge to the steady state solution? And the answer is yes, there is a steady state solution. And the steady state solution is given by minus b divided by a if a is not 0. And it will converge if a less than 0 and diverge if a greater than 0. How is that? remember again, if I have this first order linear autonomous differential equation, the solution is this. So when A is positive, k times e to the at will become infinity. So this is the profile of e to the t. So I can choose a this uh, one in example. So when t goes to infinity, the e to the at will goes to infinity also. So it means that when a is greater than 0, it will goes to infinity and it won't converge to minus b over a. But when a is negative, like example, I want to have a minus 1 maybe. So the profile when t goes to infinity, e to the at will go to 0. So I have this will become 0 and the yt will become minus b over a when t goes to infinity. So it will converge to the steady state solution when a is negative. When a is positive, it won't converge or diverge from the steady state solution minus b over a. So this is an example. A population grows constantly with the rate 1%. If the population at year 1990 is 100, find the population at year 2000. So let the population t years after the 1990 is pt. Then the differential equation will satisfy p dot. Don't forget, p dot is how the p grows with time. That is the population growth rate. That is 1%. 1% of the population at that year. So 0.01, 1% of that population. 0.01 times p. So what we want to know? We want to know what is the population 10 years after 1990. So I have 10 years after 1990. So I want to know what is P10. P at t equals 10. So I know this is the same as y dot equals ay plus b with a is 0.01 and b is 0. And the solution is given by this. Pt equals a constant times e to the 0.01 times t. So when the initial population is 0, this is this. If the population at 1990, that is 0 years after the year 1990 equals 100, so p0 equals 0. I can substitute here to here, so p0 should be a constant because this is e to the 0.01 times 0, this is 1, so p0 equals k. So I have p0 is 100 and k is 100. So pt equals 100 times e to the 0.01 times t. So the population at 2000, 10 years later, is p10 equals 100 times this. That is approximately 111 people. For the second example, this year a population is increasing with the constant rate 1% of the population at that time. Find in how many years the population will double if the growth rate is always the same. So let the population at t years from now is pt, then the differential equation is given by p dot equals 0.01 p. This is the same 1% of that population. How p changes with time is 0.01 times p. Then the population t years from now will be pt times equals k to the e 0.01 t. So I want to know what is t. So I want to know if p0 is p0, p at time 0 is p0. I want to find t such that pt equals 2 times the initial population. Okay, yeah. So from p0 equals p0, we obtain p0 equals k, just the same as before. When this is 0, 0, so p0 equals k. So I have I want to find t such that pt equals 2p0, and this is p0 e to the, okay, I want to find what is t. So I can, p0 is cancels out, so I have 2 equals e to the 0.01 t. So I can bring this to the logarithm. So I can have 0.01 t equals ln 2, natural logarithm of 2. So t equals this. So after 69.3 years, the population will be doubled. So I can review what we have learned in 2 weeks before and today. In 2 weeks before, we learned about first order difference, but today we learn about differential equation. For the first order difference equation, we have yt plus 1 equals ayt plus b, and the solution when a is not 0, a is not 1, it is given by this, and if a is 1, this is y0 plus bt. And it will converge to the steady state solution. What is the steady state solution? Steady state solution is b over 1 minus a. So it will converge when a is between minus 1 and 1. Moreover, if a is negative, it will converge oscillatory, and when a is positive, it will converge monotonously. But today we have learned about the first order differential equation, linear autonomous. That is y dot equals ay plus b, and the solution is y. This is wrong. It should be y in the brackets t equals this if a doesn't equal to 0. When a equals to 0, I have bt plus k. That will converge to its steady state solution. What is the steady solution? Is given by this. When a is negative, when a is positive, it will diverge from the steady state solution. So that's all for this week material, first order linear differential equations. Thank you.